Okay, we have a problem here where we're given a function relating x and p. So it tells us that this is a demand equation. So we've looked at demand equations enough that hopefully you remember what those variables represent when you see a demand equation. So x is number of items sold at p price, maybe in dollars or hundreds of dollars. It doesn't exactly tell us here, so we'll assume in dollars. That many number of items would be in demand at that price per item. Okay, so we've done a lot of demand equations, so hopefully that's just a little quick review there. What this is asking us to find is how one thing is changing with respect to another. Find dx dp. So how one thing is changing with respect to another thing. So we're looking at rates of change here. One important thing to notice when you look at this is what is being treated as a function of the other variable, and what we're looking at, rate of change of x with respect to p. So this is in the context of related rates problems where we have one thing changing and we're trying to decide how something else is changing. In this problem, they told us exactly what to find. It's not in words. We don't have to interpret it until our answer. But in some of the other problems we look at, it says in words some things like this, and we have to figure out what calculus thing are they asking us to find. So this one's a little bit easier in that they just give us tell us what we're being asked to find, and then we just have to do it. All right, so one thing that you might notice is that this equation, I'm going to go ahead and write the equation down here. This equation is not solved for x or p. Sometimes we have demand equations solved for p or sometimes solved for x. This one's not solved for either one. And it's actually not very easy to solve for either one. You could move a term over and square root, but then you have to think about plus or minuses and things like that. So I'm going to leave this in this form and do the problem this way. So it's telling me to treat x as a function of p, treat x as a function of p, and find a derivative. So I'm going to differentiate this equation through with respect to p. So remembering that this kind of notation indicates the derivative of x with respect to p. So we're going to differentiate both sides of this equation with respect to p. Okay, so I'm differentiating with respect to p, and this is a term that involves x, not p. But this notation is also telling me that I'm treating x as a function of p. So this is where chain rule and implicit differentiation come into play. When I do this term, I'll start by taking the derivative of the outer function, which is the square function. So I'll have 2x. And then times the derivative of what's inside the square function. So the derivative of x with respect to p. So that's really an implicit differentiation idea that's happening in that term. All right, for the rest of the equation, it's a little bit easier. Derivative with respect to p of this term that just involves p is just basic derivative rules. So minus 10p. And then the other side, derivative with respect to p of a constant, is 0. Okay, so at that point, I have found dx dp. It does ask me to find that when p is equal to 80. So I'm going to find my dx dp. I'm going to plug in p equals 80. And in order to do that, though, I'm going to have to find something to plug in here for x. So I need to know what to plug in for x. Okay, so remember that we were given this equation that I have written here, or given in the original problem, that tells us how x and p are related. So anytime you're working on these kinds of related rates problems and you need to plug a number in for something and you don't have that, look back through the problem. There's probably a relationship either that you were given or that you wrote down earlier in your work that relates your variables to each other. and you can use that to figure out what to plug in for x. So I'm going to go over here and do a little scratch work. I'm going to plug into my original equation up here when p equals 80. I'll have x squared minus 5 times 80 squared equals 8,000. And so I'll multiply this out and solve for x. So let's see. I'll have x squared equals 8,000 plus 5 times 80 squared. You can get out a calculator to do that. This would be 6,400 times 5. Oh, maybe I should get a calculator so I don't multiply it wrong on TV here. 32,000. And so we get 40,000. And I add those. This is x squared. And so I need to find x. So technically, algebraically, x would be plus or minus square root of 40,000, which is 200. Only one of those x values, though, makes sense in the context of the problem. Since x is number of items sold, only the positive value of x makes sense in the context of the problem. All right, so that's what I'm going to plug in over here for x. X equals 200. And then I'm going to solve for dx dp. So you can either isolate the dx dp and then plug in these numbers, or I'm going to just plug in the numbers first and then isolate the dx dp. So I'll have 2 times 200 times dx dp, which is what I want to find, minus 10 times 80 is equal to 0. So 400 dx dp minus 800, or maybe I'll add 800 to both sides of the equation here, so equals 800, and then divide through by 400, and so we get 2. All right, so I got an answer. Dx dp equals 2. Okay, so that's just a number answer. The hard part, perhaps, is asking us to interpret what that answer means. All right, so this is when it's important to pay attention to what the variables represent. This tells us that x is either increasing or decreasing. Since this is a positive rate of change, it tells us that x is increasing. X is number of items sold. X increases, since I have a positive rate of change, by 2. So rate of change of x with respect to p. P is price. So per 1 unit of price, per $1, if we assume the price is in dollars here, increase in price when the price is 80. That was what we were given at the beginning here. Price is 80 or $80. So another way that that's sometimes worded, especially in the online homework, it'll ask you to choose choices. So this would be an okay way to describe that. You could also use words like rate of change. The rate of change of the number of items being sold per price, change in price is 2. It's going up by 2. But another way that that could be worded so that when you choose the multiple choice things is that this is a $1 increase in price when the price is 80, or when the price is increased to $81 would be another way to say this. So the number of items sold increases by 2 when the price is increased to $81. All right, so we will look at some more related rates problems and try to interpret those answers as well.